Hey guys, so this is the rest of the lesson that we did on 8.3, the last three examples. And example 4, it starts off talking about the vertex and the X-intercepts. And so if you have a parabola that opens upward, okay, so for example, I guess I'll come over here and just draw a little sketch here. If you have a parabola that opens upward like this, then you end up, the vertex will actually be a minimum point. Okay, so if it opens upward, then the vertex will be the lowest point on the graph. If you have a parabola that opens downward, like this, then it ends up being the maximum. The vertex is the maximum point. And so the book talks about that, and it goes into your formula, ax squared plus bx plus c, talking about how that has x-intercepts, and you can, remember, set this equal to 0 and solve them using the quadratic formula or factoring. And then they talk about how the vertex is midway between the x-intercepts, basically. So if you have a parabola that has x-intercepts, let's look over here, let's say here and here, the vertex is halfway between those two x-intercepts. So that's really useful, especially in graphing. And so on this example, we're going to just use the vertex to graph, and then we'll plot a few more points. And then on the next one, we'll use the x-intercepts and the vertex to graph it. And so the way to find the vertex is really nice. It's part of the quadratic formula, believe it or not. It's the part without the plus or minus the square root. Okay, so you have that negative b, which is out in the front of that quadratic formula. And remember, it's all divided by 2a. So this is actually the formula to find the x-coordinate of your vertex, the highest or lowest point. So let's look at this example and find the vertex, and then we can find a few more points to graph it. So notice in this example, the leading coefficient here is -1. So remember, that's the one out in front of x squared term, that's an a. So a equals -1. B is the one out in front of the x term. So b is equal to -1. And then c equals 2, but we don't need that. So in order to find our vertex, we want to say, okay, x equals, it's negative b, so it's negative times -1. So -1 all over 2 times a, which is -1. And so really these two would just cancel. You'd end up having -1 over 2, but we'll go ahead and multiply this out. So negative times -1 is +1, and 2 times -1 is -2. So you can just say -1/2 is your vertex. Now, the interesting part about this is to find the y-coordinate. If this is our x-coordinate, remember, we can actually plug that back into this formula and get our y-coordinate. So our y-coordinate, or f of x, right, is going to be when x equals -1/2. So if we plug that into here, we'll get our y-coordinate. Okay, so this is -1 times -1/2 squared minus -1/2 plus 2. Okay, and I won't go into too much detail about that, but it ends up being 9/4. Okay, so if you were to multiply that out, remember, do exponents first, and then you'll have to get a common denominator for that, 4, but it ends up being 9/4. And the reason I'm going over that quickly is because I'm running out of room, and want to make sure this video is not too long. But then this says once you find that vertex, then you can actually plot that. So actually I'll go ahead and plot it. So -1/2. So here's 1, and halfway would be the 1/2, right? So -1/2, and then 9/4. That's a little over 2, basically. Okay, so 2 1/4. So we'll go up a little bit, and then we'll try to just kind of put it about 1/4 of the way up. So that's where the vertex is. And then in order to figure out how to plot the rest of this thing, we can do an X and Y chart and pick points around, the ones that are around the vertex. Okay, so what's near -1/2? You know, so think about those values. So definitely, you know, kind of plotting the same ones that we've been plotting. We can do -1, we can do 0, -2, 1 and 0, or 1 and 2 again. We can do those points. Those are all, you know, pretty close to it. I would probably at least plot, I'd say, you know, 5 points, just so you get a nice curve. And so now if we go back to this function and we plug those in, we're going to end up, so we're going to get negative times -2 squared. So I'll go ahead and write this in. -2 squared minus -2 plus 2. So if you were to do that, this would be 4. So it would be -4 plus 2 plus 2. So that ends up being 0. So this is -2, 0. So if I come over here, I can plot that. All right, -1. So this will be -1 squared minus -1 plus 2. So this will be -1 squared is 1. That's -1 plus 1. So that's 0 plus 2. So 0 plus 2 is 2. So now we can plot that, -1, 2. So that's here. You can kind of see that shape. If that's the vertex, you can see the shape of that left half of that graph. 0, if you plug in a 0, so up here, I'll just write it. Okay, so 0 squared, 0, 0 times -0, minus 0, plus 2. So this is actually a 2. And so if we go 0 and then up 2, I plot that point. So I can see, again, this is the left half of this graph. And then I can tell the right half, what it's going to do is come down also. Plugging in the 1. So 1 plus 2. I wanted to put my parentheses in, but 1 squared is 1. And then you got -1 minus 1 is -2 plus 2 is 0. Okay, notice again the symmetry here that we're getting. So 1, 0. So actually we can stop there. We really don't need to plug in another one. 5 points is probably enough. Okay, so you can kind of see what that looks like. So again, example 4 just has you using the vertex to plot and then finding some other points. And then if you want to continue this on just the very end, we need to state the domain and range. Again, it continues to grow left and right. So the domain is -infinity to infinity. The range, the highest point, remember, is the vertex. That's the highest point on this one. And so it's 9/4. And we have, again, don't forget, it's going down. So we have to put the -infinity first. It's -infinity up to 9/4. And then we put that bracket because it includes the 9/4. So that's example 4. Example 5 is really similar. Okay, you're using the intercepts to graph it, and you're still going to use the vertex. So again, this is example 5, and I'm just going to do A. Okay, I can at least talk about how to factor B, but again, just want to try to cut this video a little bit shorter. So this is a 2x minus 8. So again, with this one, go ahead and find your vertex. So x equals, remember, negative b over 2a. Again, this is b, okay, negative 2. And if you need to, write these out. A equals 1, b equals negative 2. Again, c equals negative 8, but we don't need it. So negative b, negative times negative 2 over 2 times a. Negative times negative 2, positive 2. 2 times 1 is 2. And so we end up getting a 1 for x, which is really nice. We can find that y value. So y equals, let's plug in the coordinate for our x into here, and we'll get our corresponding y value. So y squared, so 1 squared, sorry, I meant x squared, 1 squared minus 2 times 1 minus 8. So 1 minus 2 is negative 1, and negative 1 minus 8, negative 9. So this time we've got our vertex at 1, negative 9. Okay, so when I plot this, being as I didn't go all the way down to negative 9, I'm going to treat these, we're going to count these by 2's. Okay, so this will be considered 10 all the way out here. So we'll have, counting by 2's, 2, 4, 6, 8, 10. So if I go down, this will be negative 2, negative 4, negative 6, negative 8, negative 10. So we're going to plot this 1, negative 9. So I'm going to go halfway, because that would represent the 1, and then go down to negative 9, which would also be halfway here. So there is negative 1, or yeah, 1, negative 9. And then a different way to do it, instead of making an x and y chart, we're actually going to factor this and use those values to find the zeros and then plot those zeros. So again, if we set this equal to 0, f of x equals 0, and we have x squared minus 2x minus 8, we can factor this. So again, think of two numbers that when multiplied give you negative 8, but when added give you a negative 2. So that would be a negative 4 and a positive 2. Okay, that actually works out. And so set each of these equal to 0. Actually, I want to do this first. X minus 4 equals 0. It's going to get ready to solve it. X equals 4 if you add 4 to both sides. X plus 2 equals 0. Subtract 2 from both sides, you get x equals negative 2. And so now I know I can plot, this is a 0, so this is 4, 0. Okay? And this is negative 2, 0. Those are 2 more points I can plot. If I do that, I don't need to find additional points, really. I can just try to draw a curve here. So 4, 0, recall again, we're counting by 2's, so this is 2, 4. So we plot that one, and then this one's negative 2, 0. So there's our parabola. Just kind of bring it up like that. And now we can find the domain and range of each one if we want to. This one doesn't ask for that, so I'm not going to do that. The final example is example 6. It says if a projectile is launched with an initial velocity of v0 feet per second from an initial height of s0 feet, then its height s of t in feet is determined by the quadratic function that's listed there, and I'm going to give that to you. So for this one, they give you this quadratic function, and they tell you that the height, s sub t, is negative 16t squared plus v0 t, that little 0, it's like the initial velocity, times t, and then plus the initial height. That's what that means. And it says where t is time in seconds. If a ball is tossed upward with a velocity, an initial velocity, of 64 feet per second, so they're saying that v0 or initial velocity is 64, from a height of 5, initial height is 5, they're saying if that's the case, then what is the maximum height reached by the ball? Okay, so I'm going to write this in. So we're going to say plus 64t, because v naught is equal to the 64, then plus 5. So that's your equation now, and it asks for the maximum height. Sometimes, it's nice to solve for, when it starts, when it hits the ground, but that's not what it's asking for here. Normally we would factor this, but we don't have to. All we have to do is find the vertex, because that would be the maximum height. This parabola is facing downward because of the negative out in front. So yeah, all we have to do is find the vertex. Recall, a vertex is just x equals negative b over 2a. So going back over here, b is 64. So we're going to say negative times 64, which is b, all over 2 times a. A is negative 16. So it's negative 64 over 2 times negative 16 is negative 32. And then that equals 2. Okay, so, and again, I know I said x here. It represents t in this problem. So that's going to actually be t equals. I know we're so used to just using the x, but that'll be the time. And so the time will end up being 2 seconds. And then they want to know the maximum height. That's just the time that it reaches the maximum height. So you have to plug it back into the function to get the height, the actual height at 2 seconds. So if we do s of 2, we'll be finding our height, our maximum height. So negative 16 times 2 squared plus 64 times 2 plus 5. And if you plug that in, you end up getting 69. So the maximum height is 69.